Hello, RoboCon. Is, is everyone enjoying the event? Yeah. That's great. I'm coming from India with love. And if you're wondering where in India, I come from the southern city called Chennai. Today, I'll be exploring the world of ETL test automation with robot framework. My name is Rohit Ram Prabhakaran. I work for the company Tata Consultancy Services, which is a global IT consulting firm. I'm a test automation architect. I'm a data warehousing testing expert. I'm also an automation trainer and coach. Before we get onto the topic, may I know how many of you work with testing of data? When I say testing of data, not just testing with your test data, but testing if your data is correct, like completeness, correctness, accuracy, and so on. Great, quite a few hands. Great. So let's see, why is data important? Data helps us in better decision making. It provides us evidences that helps us to avoid human preferences and biases. It can help us to identify problems even before they occur. Hence, we can tackle or we can avoid them accordingly. Many a times, when we do planning, it's always based on our gut feeling. But with data, it helps us to transform this gut feeling planning to a strategic planning so that it can put to a better execution. With historical representation of allocation of resources, we can make use of the historical data and make better utilization of resources for allocation or doing any task. Data is also widely used in business growth. It helps us to understand the nature of our clients, the target markets, the demographics which they operate, and their target sales or some sort of that. All these helps us to build up better business models for our clients and hence more happy clients. All in all, data not only reduces cost and improves efficiency, it overall reduces the quality of life for all of us. Do you know how much of raw data from a supplier can be actually consumed for a business purpose? Any rough guesses? 10%, 20, 30, 90? A recent research suggests only 40% of the actual data can be consumed for a business use. So that means data should undergo some kind of a transformation before it is actually suitable for a business purpose. This picture clearly explains what a data, when it's sorted, arranged, and visually presented, looks like. And when it's presented with a business story, it makes more sense and more value to the business users. What are the different data transformations? As I said, data needs to undergo some kind of transformation to be actually usable. Some of the common techniques are data cleansing. For example, let's say a customer opens account in different banks, but if he's reported as two different customers when he opens two different accounts in different banks, then that's a duplication. We might potentially need to identify this duplicate and do a deduplication and report it as one single customer with two different accounts. Handling of missing values. Let's say when it comes to a reporting and it has some missing values in between, the overall report doesn't really make sense. So handling of this missing values and identifying this is very important. With respect to inconsistencies, we often face, let's take an example of one of the viewing patterns with a market research client. So it's just viewing of campaigns. Each one has been reporting, or each provider has been reporting the viewing pattern in different time zones. So that leads to inconsistent reporting. So we have to consistently report based on GMT or some kind of a specific time zone. So handling all this or testing all this is very important. Next one is the aggregation of data. Many often with sales, we do report data on a weekly, monthly, or a quarterly basis. Hence, this kind of aggregation testing is very important. Joining of data. Not every time the data from a supplier is from a single source. I was once working for a market research client wherein we had 18 different providers for a business use case. Hence, Joining of this data across the providers is very important. And testing of it really makes a lot of business value. There are other forms like logarithmic transformations, arc-sine transformations, but I will not really dwell into it. But if you're interested, you can check that out. ETL testing. What exactly is ETL or ELT testing? ETL is a process of extracting, transforming, and loading data into the target database. This ensures that the data has correctness, completeness, and accurate when we load into the target systems. The right side architecture shows a very clear and a simple diagram wherein data can be taken from multiple sources. The sources can be of single or different databases, or it can be of different file systems, like it can be a flat file, an XML file, or a JSON file. Then it undergoes some kind of a transformation, and it gets loaded into the target ecosystem or the target table. This is nothing but the ETL architecture, very simple one. Due course of time, with the growing volume of data, the transformation took a lot of time and occupied a lot of space in the cluster or the server. Hence, it paved way to the ELT testing format or the ELT transformation format. Here, similarly, multiple source data is there, but we load all the source data into the staging zones of target ecosystem. Then we do the transformation. Hence, the load is not on the independent server, but on the target system. And this is the ELT architecture. Overall, from a testing perspective, ETL and ELT can be seen as almost a similar structure. But what we really test for is how the data from the source system is transformed into the target system and what is the logic behind it. When do we do ETL testing? When a new system is arrived or a new provider is getting joined with the existing providers, then it calls in for a data testing or ETL testing. When we migrate from a present database to a higher version, or we take a new database or change it to a much flexible one or something, then it calls in for an ETL testing. Then the report testing. Not often the business users come to a database and look at the values. They simply look at some kind of a UI screen to make sense of the data and then use it for business purpose. Hence, report testing of projecting the data values from a database onto a UI screen is very important. Next one is performance testing. Many often, this is a skipped part, but this is very important for the reason data is growing day by day. So the volume occupied on the cluster or the server is going to increase, and we need to be very sure when the cluster or the thresholds that the cluster can handle or when it can actually break. Next one is the metadata testing. With metadata testing, we test the primary keys, we test the data types of the columns. Also, we test the constraint checks. Next is the data quality testing. Data quality testing is a wide topic by itself, wherein we verify many aspects like accuracy, consistency, and so on. I've given a detailed talk on data quality testing in my previous RoboCon online conference. Mostly the video should be on YouTube. You can just check it out. Data transformation testing and incremental ETL testing is what I'll be covering in depth in a use case which follows. Okay, how do I read the requirements, or what kind of requirements do I get for this ETL testing? Most of the times when it's a UI or API testing, the requirements are in different format. But in ETL testing, mostly it calls for this kind of a requirement. There are many tools to show these requirements, but I have just taken an Excel rows and column specification for the ease of use. So it has a target system and a source system. It specifically says what is the date that the requirement is provided, the name of the target table, the target column name. If it can be a nullable column, if it's a primary key column, what would be the data type and length of the target column? Again, it says from which source table it is taken, name of the source column, the data type, and the length of it. Then it specifically says what kind of transformation expression it needs to undergo for the source data to go into the target column. And if the source data is missing, what data needs to be in the target system. It says the default value as well. Finally, When we have an unexpected data in the source, what kind of error handling scenario should be there? Again, this is just an example. It can have few other columns as well. Depends on the system. Let's take a simple transformation mapping document as a use case. Again, what we have in the enterprise level is not going to be this simple. This is just an example to explain about ETL system. And I've taken this example in an automation suite as well to explain how you tackle this scenario. So it has a target table. For easiness, I have just kept it as target table. And let's consider the first record. The ID column comes from the employee ID column in the source table. Both the columns are not nullable in source and target. It is a primary column. But the interesting fact is, in the source system, it is a string, and the target is an integer. So we need to check the data types as well here. And another interesting thing is, the source has the length 25, but target truncates it to 20. So there needs to be boundary value testing here as well. There's no default value to the column because it's a primary key column. And if it's not present, it is going to fail the job. On this particular use case, overall, if you look, it says something about the employee payment system. Or for this example, we can consider the use case as a global consultancy, which has its employee across different parts of the world, and each one gets paid in their local currency. So different employee systems or different employee categories in different countries in different currencies is what we are looking at. So if you look at the whole system, currency, code, name, and address are correspondingly taken from other source tables like table 2, table 3, from corresponding columns. As I said, this is just for the example's sake. And this is how a real-time mapping document might look like. It's a bit hard to read with all these different transformations. Let me take two different examples to explain how we test it in real time. Let's consider example 1, where if we have employee department table, employee table, and departments table. If the employee ID is matching between the first and the second table, and the department ID is matching between the second and the third table, then we take the employee code, assign it to the department code in employee dimension table. This is one such transformation example. The next one talks about aggregation. So we have two tables, employee contract and currency conversion table. The currency is CC, and the contract date is between the start and the end date. We take an average of the currency conversion, and we assign it to rate amount USD column in the employee fact table. So this is how we test a real-time scenario. Now, let's go to the automation stack. Again, this is not a real-time example. I've just taken samples from different implementation from different clients. And this is an architecture or the pattern for the speak purpose and does not reflect any implementation which is actually followed for any clients. So we have our application hosted on Hadoop. It has Hive as a database system and Hadoop file system as the server system. We chose robot framework with Python, of course, as the automation tool. The automation framework is a modular and a data-driven framework, which has event-driven approach as well. We chose Jenkins for CI/CD and Bitbucket for our version controlling. And we had the flexibility to run these tests in test and development environments, depending on business cases. Our team is comprised of a vast team member, like around 30 team member, which can have Python experts to Python beginners, to ETL experts or ETL testing experts to ETL testing beginners. So we wanted to keep the structure very linear and easy to follow so that people don't find it difficult to get into the system. We have kept our low-level and connection keywords in connect keyword.resource file. And these keywords are in turn called and put in the transformation setup keywords, which do have other keywords for the transformation setup. And with respect to the tests, they're separated module-wise, and each module has different jobs. Let me give an example of one job, and the other jobs similarly follow the same pattern in a modular way. So this job contains a config file, expected target data file, and different source data files. It also has the robot test case files. Let's see what these files are one by one. Configuration file simply says or gives the input to the transformation job what it needs to actually do. So it has the details like the module name or the job name, which is nothing but the transformation name, and then the environment to execute, test or development. It has the details of source, target, and metadata and table names. Lastly, we do have table name prefix. This is something interesting. Why do we have table name prefix? So, since I said there are many team members, I use 3 sources and 1 target table. My target table can be source system of my colleague's test requirement. So that means when I run a suit setup or tear down, I might delete the tables and reload it, which might potentially affect my colleague's execution. To avoid this, we chose a table name prefix for each of us so that each one's run is independent of others and we do not delete or modify their tables during my execution. Next is the source data setup. We chose CSV as the most comfortable format for this. The normal RDBMS, we could directly load CSV data into a database system, like an Oracle system. It's easy to load that way. But in Hadoop, we actually need to load it into the file system, Hadoop file system in a compressed format, like Avro or Parquet, and then build external tables on top of it. And this increases the efficiency of the performance in Hadoop. So we chose CSV for this reason, that it's easy to place and compress into an Avro, Parquet, or whatever compression format is required. As you can see, I've mentioned 3 different tables. And any guesses on the similarities between these tables? So they do have similar data. If you see the first column, it has the same data. So this enables to have mapping or joining these tables to get the actual test result data. So it also has the columns that we need for our business purpose and some other columns which might not be needed. Next is the target data file. So based on our mapping rules, we do prepare our target data files in a JSON format. Why JSON? I'll explain while we do the comparison step. Again, this says, based on the requirement, what would be the target values and the column names. Once we prepare these files, what we need to do is place this application configuration file into the server or the edge node, along with the application job. So application job resides in a code repository from development environment. And based on the version that we give, that comes from our requirement or the deployment notes, we'll give that corresponding version for testing. And that particular application version gets deployed into the server. Once these are deployed, we are good to run the application. In this case, I've taken application code as a very simple compressed shell script. And based on the parameters given, it will execute the application job. In this example, I've just given 3 parameters like transformation name, config file, and date. But in real time, we can have a lot of other parameters which can say what we need to run or for which specification we need to run the application. Few of the ones are listed here. I'll go over one by one. One is the module name and the job name. Next, a same requirement can have multiple configuration file depending on the requirement nature. So we'll choose which config file to take. There should be a specific period to run these tests. For example, a provider can give the data only after 2025. So if I run this job for 2024, it's supposed to fail. So I need to specify the period as well. Next, the environment, test or development. Code version, we already spoke about it. And the table name prefix. Lastly, we have this second run flag, which helps us to test slowly changing dimensions. What is this? Let's consider a banking application wherein a customer sends data around 11:55 p.m. in the night, and it said that the transaction has gone through. There's a 12 o'clock feed that takes this data and supplies to the downstream systems for the business analytics purpose. But let's say at 12:06, 6 past 12, the transaction has been declined, the customer got back the money. So what happens in the next day, there is another set of record which says, there is a new record which says transaction has failed. And how the first record behaves to it is called slowly changing dimensions. There are different formats and patterns to this, to test these slowly changing dimensions. But this second run flag helps us to do that. Or in simple words, second run flag will not do a tear down process. It will simply lead our files or leave our files in the target database so that the second or the third day's process also happens and we test those dimension changes as well. So once the application job is run, we need to read the output data from the Hive, and we use a basic Hive query language. And the return is form of a list of dictionaries. So I've given a very simple query here, which says select star from a table and for the given schema. It's always advised not to filter out the data at the SQL level. For the reason, it might occupy a lot of space on the cluster and it might slow down the system and affect other executions as well. So it's always advised to read the whole data. Again, we do not cross hundreds or let's say 200 to 300 different combinations of test data. So it's always better to read those data and do the filtering on the robot side or the automation side. So the idea is to read the whole table data and store it in a variable called actual data. Next, we have our test case files. It says what is the business logic in the documentation section. Why do we have this transformation? Next one, we have the setup keywords, which says the transformation setup and calls those keywords from the high level, which in turn calls the connection keywords as the low level ones. Then we have the suite setup, which comprises of all these steps, right from our config file to our reading of output data. Then we have our tear down, which clears out the target table HDFS files, the files on the edge node, the application, the config files as well. Finally, coming to our test cases. Test cases, we wanted to keep it again very linear, not to have much of steps there. So the reusability also increases or is much easier. So in this case, ID is a column that I'm going to verify. And the documentation simply says, where is this column taken and from which table? And the test step is a very simple step where we embed the column name as a variable, and then we compare against the source and the target data. So this is how a comparison step works. So we have our JSON file, which is much similar to the output table format. So we have taken the data from the output table, stored in a form of list of dictionaries. JSON on one side and list of dictionaries on the other side are almost the same structure. So it's easy to compare. Then we take each row by row in a for loop and then compare each of the columns. And if needed, we do compare the data types as well. Hence, after this comparison, it simply says whether our column name from the source and target are matching. So this is how we tackled a large ETL system and kind of automated the whole structure. We automated close to 6,000 different data attributes or columns. Again, these are not one-time ones, so there are incremental requirements for these attributes as well. Let's say for one manual verification of one job, which has around 20 data attributes, if an expert developer or an automation engineer does this, it takes 3.5 hours. But automation, it saves close to, let's say, 3 hours, excluding the test data preparation. All in all, with automating 200 jobs, we save 600 person hours of regression timing for each fortnight. Overall, for the given 4 years, we have saved more than 7,000 person days, which is again a very huge saving. This not only saves time, reduces the SDLC lifecycle process, but it has also increased the bug identification rate and hence lead to a better quality of product. Just to summarize the flow, we do have the config file, test data file, preparation, source and the target data, the robot test case preparation. Then we load the application job and the config file to the server, run the application job, read the output data, compare the output data, check whether the test case has passed or failed. I honestly believe no technology has saturation. There is always a minor scope for improvement. In this case, the first 4 steps that you see in the chart are still being done manually. Although not very large effort is consumed here, but still, we wanted to avoid this manual effort. Hence, GenAI comes into picture. So the future roadmap is such that we wanted to use the abilities of GenAI to automate these processes as well, so that the entire system or the entire life cycle of test automation is much further reduced. Hence, what are we looking at? We are looking at AI-enabled test scenarios generation. So based on the requirement mapping document, AI will tell me what kind of scenarios I need to prepare and have it. And then AI-enabled test case generation. So based on the scenarios, it is going to prepare my test data in the source file and the expected files automatically in the given format. And then I can simply reuse them in the test data files. Finally, my automation robot framework scripts are also going to be prepared by AI, which is potentially going to be used. And we are in the early process of this, and we are going to implement for a very small client. And then based on that, we are going to improvise and take it forward. I would like to take this moment to thank my company, Tata Consultancy Services, for helping me to learn and grow. I would like to thank Robot Framework Foundation for giving me this opportunity to share my knowledge. And lastly, I would like to thank my mom and dad, Prabhakaran and Thinmuri, for always supporting the decisions that I took in my life. Last but not the least, I would like to thank my wonderful wife, who's taking care of a 2-week-old baby at home while I'm passionately doing what I like. Thank you.
Thank you, Rohit. Questions? There. Oh! Yeah.
Hello.
Yeah.
So let's assume you have 3 jobs, and every job you have 200 tests. So you have three packs of the tests. And let's assume that you want to run it simultaneously, parallel. But the problem is that the data that the jobs using is kind of
Interrelated.
So they kind of interact with some, say, one table. So how do you solve this problem? Can solve this problem and still remain a parallel execution?
Okay, one idea is to use Jenkins and pass the prefix values as I told you. So each one of the testers can use a prefix value. For example, I chose my prefix value as RR, which represents Rohit Ram as QA, RR underscore QA, and then follows the table name. So if I need to do parallel execution, even in the runtime argument, or I can do it in Jenkins, I'll specify RR underscore QA underscore 1, 2, or 3. So we can play around with the table name prefix and have parallel executions.
More questions? Anyone? All right. Rohit can be found from the speaker's corner in the next break. Thank you, Rohit. Let's thank Rohit once more.
Thank you, everyone.
You're almost done.